Hey bio team. Before we go into the different types of molecules and chemicals that living things are made out of, I wanted to do a quick review of chemistry in general. So this here is a lithium atom. These red things with the positive sign inside them are protons, which have a positive charge. So the number of protons are what makes this a lithium atom. The number of protons an atom has determines its elemental properties. So if an atom has one proton, it would be a hydrogen atom. If it had two protons, it would be a helium atom. And if it had three protons, it would be a lithium atom. And so you can see the atomic number of an element just represents its number of protons. So these gray circles here represent neutrons, which are neutral electrically. They don't have a charge. However, they have a mass of one atomic mass unit. So together with the protons, this nucleus of the lithium atom would have a mass of 7 atomic mass units. And so the average mass of all atoms of an element is generally shown at the bottom of an element's tile on the periodic table. Now, because these protons are positive, they will attract negatively charged particles. We'll show that here. And these negatively charged particles are electrons. Now, because there's 3 protons, at least initially, these will attract 3 electrons. And so you'll notice that these electrons attract into shells around the atom. Initially, they attract as close to the atom as possible, into inner shells called core shells. But eventually, there isn't enough space for these electrons in the inner core shell here. And as a result, the electrons will repel each other out into a second shell, which in this case is the outermost shell, also known as the valence shell. And you'll notice the electrons are filling into these spaces of up to 2 electrons. Those are just called orbitals. So we'd say that this atom overall is neutral because it has the same number of positive protons, 3 positive particles, as negative electrons, 3 negative particles. So overall the charge is 0. However, we would say that this atom in its current neutral state is not stable because a stable atom has a valence shell that is completely filled with electrons. So what this atom can do is it can find an atom of a different element, in this case a fluorine atom, that would need 1 valence electron in order to become stable. You can see that this fluorine atom, its valence shell isn't completely filled, but it only needs 1 valence electron. And this fluorine atom will attract the electron away from the lithium atom. And in the process, stabilizing both of these atoms' valence shells. The lithium atom now, its new valence shell is its old core shell. This first shell is now its outermost shell. And that has 2 valence electrons out of 2 possible valence electrons. It's completely filled. And the fluorine atom now has 8 out of 8 valence electrons instead of 7. Now that said, these atoms are no longer neutral. Because the lithium atom has 3 positive charges, and now it only has 2 negative charges, its overall charge is no longer 0, it's positive 1. It has 1 more positive than negative. And the fluorine atom, because it gained an extra negative electron, now has a charge of negative 1. And so we would call these 2 atoms now, we'd call them ions, which are just atoms that have charges, an imbalance of protons and electrons. And because these ions are oppositely charged, they'll attract each other. So we'll watch that happen here. And we call this connection that forms between these oppositely charged particles an ionic bond. But this isn't the only way that atoms can bond together. If there are 2 nonmetals, for instance hydrogen and fluorine, each of which would need to gain 1 electron in order to fill up its valence shell, what can happen is that the nonmetals end up sharing their electron orbitals. So now this hydrogen atom has access to 2 out of 2 valence electrons, and this fluorine atom has access to 2, 4, 6, 8 valence electrons filling up its valence shell. And so we call this type of bond a covalent bond, literally where valence orbitals come together. Co meaning together, valence meaning the outside shells. Now it's also possible for atoms to share more than one orbital in a double covalent bond, or even share up to 3 orbitals in a triple covalent bond, as we can see these 2 nitrogens doing here. Or even share orbitals with more than one atom at a time. And so you can actually see through covalent bonding, atoms bonding together into these very large macromolecules. Now when 2 atoms share these electrons equally, we call it a nonpolar bond. Each nitrogen is attracting these shared electrons with equal strength because they're the same type of element. However, sometimes one of the elements in a covalent bond has a higher electronegativity. That is, it has a stronger ability to attract electrons. So in this example, since fluorine has the higher electronegativity, it will attract these shared electrons slightly closer to itself. And in the process, this makes the fluorine atom just slightly negative because it's slightly attracting these negative electrons. And because the hydrogen atom is just slightly losing these negative electrons, the hydrogen atom becomes slightly positive. And so we call this type of covalent bond a polar covalent bond, where the electrons are pulled to one side of the molecule. Now what's important about this imbalance in a polar covalent bond is that it gives polar molecules the ability to attract to each other. Because a polar molecule has a slightly negative and a slightly positive side, it is able to attract to the opposite charged sides of other molecules. And so an important example of this comes in water molecules. In a water molecule, H2O, the oxygen atom has a higher electronegativity than the hydrogen atoms that it's sharing electrons with. And so as a result, the electrons that oxygen is sharing with the hydrogens attract slightly closer to itself, making oxygen slightly negative and the hydrogen slightly positive. And this allows the water molecule to attract other water molecules. The slightly positively charged hydrogens can attract to the slightly negative charged oxygens. And in water, we call this attraction between molecules a hydrogen bond. Now what's interesting is that nonpolar molecules are not attracted to polar molecules like water because they have no positive or negatively charged sides to attract. And if there's no opposite charges, there's going to be no attraction or interaction between the molecules. So to describe this, biologists will say that polar molecules with their positive and negative sides are hydrophilic, whereas nonpolar molecules, like this benzene ring, are hydrophobic. That is, they're not attracted to water. And that's it. At this point, you guys have a couple of practice problems. We'll see you next class.